9th graders, see you again in Penabur Online Learning. From your previous lesson, you have learned about board electron configuration. And you must use special rule when you make electron configuration of atom with atomic number that greater than 18. Like, for example, when you have a calcium atom with 20 atomic number and 40 atomic mass. So it means calcium has 20 electrons, and using board electron configuration, we are expecting to get the electron configuration is 2, 8, and 10. But actually, the electron configuration is not written like that. It's supposed to be 2, 0.8, 0.8, and 0.2. First shell actually can have 2 electrons, and second shell actually can have 8 electrons, and the third one can have 18 electrons. But then this electron is not distributed as 2, 8, and 10, but it is distributed as 2, 8, 8, and 2. So why this can be happen? By the quantum mechanical model of atom, which has orbital or subshell, and Aufbau principle in electron configuration, it will make us understand about the reason why it's happened. The Aufbau principle or Aufbau rule states that in the ground state of an atom or ion, electrons fill atomic orbitals of the lowest available energy level before occupying a higher level. And the order of orbital energy level is given by this scheme. The Aufbau principle put the orbitals based on the order of the shell. The first shell will have orbital 1s, and then the second shell will have orbital 2s and 2p, and then the third shell will have orbital 3s, 3p, and 3d, and then for the fourth shell will have orbital 4s, 4p, 4d, 4f, and so on. But the order of energy level from the lowest to the highest is starting from 1s, and then 2s, then 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, and so on, following the arrow symbol on the diagram. So if we have some amount of electron, the electron will fill orbital 1s first, and orbital s can have 2 electrons, and then the remaining will be used to fill 2s, since orbital s, so it can have 2 electrons as well. And then the next that need to be filled is 2p, which has 6 electrons or can have 6 electrons. And then it will go to 3s, which can have 2 electrons as well. And then it will go to 3p, which can have 6 electrons. But from 3p, we will go to 4s, following the arrow symbol on the diagram. So after 3p is full, the electron will be used to fill 4s, which can has maximum 2 electrons. And after that, the remaining electron will be used to fill 3d, where it can have 10 electrons. So the order on how we fill the orbitals in Aufbau principle must follow that diagram. The next principle that used in electron configuration mechanical quantum model is Pauli exclusion principle. Using this principle, it says that 2 or more electrons cannot occupy the same quantum state inside an atom. Or in other words, it cannot have same value on 4 quantum numbers. The next rule is Hund's rule. Hund's rule says that every orbital in a subshell is singly occupied with 1 electron before any one orbital is doubly occupied. And all electrons in singly occupied orbitals have the same spin. So we can take a look here for carbon. Carbon has 6 electrons, so the first 2 electrons will be used to fill orbital 1s, and then the next 2 electrons will be used to fill orbital 2s, and the remaining 2 electrons will be used to fill orbital 2p. But it will be used as a single electron that will fill all the spaces in 2p. Cannot put them in pair if there is still an empty orbit. Before we discuss further, we will take a look at the periodic table. For our discussion, we will only discuss about elements from group A. They are 1A, 2A, 3A to 8A. Before we discuss more, group in periodic table is actually have elements that are located in the same column. And we also have period that will show us the element from the same row. So we have period 1 starting from hydrogen and so on, and then period 2 starting from lithium and so on, and then period 3 from sodium and so on, period 4 from potassium and so on, and period 5, 6, and 7. In order to get the quantum mechanical electron configuration, for example, electron configuration of carbon that has number of electron equal to 6 and number of proton equal to 6, and the number of neutron is equal to 12 minus 6 equal to 6. In order to get the information about electron configuration, we just use the information about its electron number. So starting from orbital 1s, so it can have 2 electrons. So the 2 electrons will be used to fill orbital 1s with 2 electrons. And then the remaining will go to orbital 2s. Orbital 2s can have 2 electrons. So at the end, we still have 2 remaining electrons that will be used to fill orbital 2p. So that 6 electrons will be distributed in orbital 1s 2 electrons, 2s 2 electrons, and then 2p 2 electrons. So the quantum mechanical electron configuration of carbon is equal to 1s2, 2s2, and 2p2. We can simplify this configuration using 4 electron configuration, become 2 and 4. Since in the first shell there are 2 electrons and on the second shell there are 4 electrons. Now there's something special about this electron configuration. 1 in 1s is identified in the first shell, and then 2 in the 2s and 2p is actually telling us that this is actually in the second shell, or the outermost shell that filled with the electron. This 2 is actually the electron on the first shell, and then this 2 and 2 is actually the electron in the second shell. So if we take a look in the periodic table, carbon is located at period 2 and group 4a, where we can find 2 or the period is actually the outermost shell that filled with the electron. And the group 4a is actually telling us the total electron in the outermost shell. That's how we can make electron configuration using quantum mechanical. So now you can try to find its quantum mechanical electron configuration of calcium, and let you know why this calcium has electron configuration 2, 8, 8, and 2. You can try to get more electron configuration of several elements from the periodic table. And I think that's all for this video. Thank you for watching. God bless you.